Hi dear students. Okay, so how is it going, the NEET preparation? I hope all of you are doing good. Okay, so today we are going to deal with another important video on electrophilic addition reaction. So some more videos are coming on the same section, and we will cover all important questions based on this particular concept. And those who have missed our previous sections, so you can go to our playlist and watch the electrophilic addition reactions, the other videos. Surely it will help you. We can expect one sure question from this particular topic. Okay, so all of you listen to it, and if you have a doubt, please put it on the comment box. So the question here is, in the reaction with the HCl, okay, an alkene react in accordance with the Markovnikov's rule, okay, to give a product that is 1-chloro 1-methyl cyclohexane. Now they are asking you which is that alkene. So we can say there were some alkene, okay, we don't know what it was. It can be option 1, 2, or both 1 and 2, or even 4. So that react with HCl as per what rule? Markovnikov's rule. To give a product that is 1-chloro 1-methyl cyclohexane. So what is this alkene is? Okay, they are asking you which is that reactant. Normally they will ask you the product. Okay, so let's try to analyze this question. So this is the product that they have given to you. Okay, so this is the product that is what they have given to you. That is, you can see here 1-methyl 1-chloro cyclohexane. Correct. Now we need to analyze how we can arrive at this particular answer. So this is my what? Product. So this is my product actually. Now let me take the option A. This is my option A that is given in the question. Okay, now what I am doing, the strategy I am doing is I am taking each option one by one and doing the addition of HCl and checking whether I am getting the expected product. Okay, so here I am taking the HCl, and you can see the HCl will undergo heterolytic fission. So you will get H plus and Cl minus. Why Cl minus is coming? Because chlorine is more electronegative. When this bond breaks, the two of the electrons will go to the chlorine atom. Okay, now we know that here pi bond is present, correct? So the pi electrons are there. So here what cloud would be present? Fundamentally a negative charge cloud will be present. So who will first attack the pi bond, or who will first come near to the pi bond? The electrophile. So out of this, the electrophile is H plus, you can see here. Okay, now the H plus will approach the pi bond. So what the pi bond will do, sir? We know that the pi bond will have a Coulombic attraction from the positive charge. So this will undergo ionization. Now the ionization will happen in such a way that you will get a stable carbocation, because we know that it is an electrophilic addition reaction. Why? Because electrophile is first approaching the pi bond. Now this will polarize towards the top. So a negative charge will come here. Okay, and positive charge will come here. Now some students may ask doubt, sir, why can't it polarize in the other way? If you do it like that, you will get a carbocation which is a primary carbocation which is unstable. Now you are getting a carbocation which is tertiary in nature. So we know that tertiary carbocations are stable. So next what will happen? The approaching H plus will attack the negative charge, and you are getting the reaction intermediate which is a carbocation. Now what will happen, sir? We know in the next step of electrophilic addition reaction, the nucleophile will approach the negative charge. So nucleophile will approach the negative charge, and it will donate electrons to the positive site. So what you will get? You are getting a compound what is given in the option. So what is the name of this compound, sir? You can think in the first question itself, CH3 is present and chlorine is present. So that means 1-chloro 1-methyl cyclohexane. Correct? This is what it's given as the product. But we should not stop here. We should check for other options as well, since both A and B are present. So I am taking the option B again. You can see option B I have taken. Now here also the same thing I am doing. I am ionizing the HCl. So negative charge electrons will go with the chlorine, and the H plus will be formed, and we know that here pi bond is present, or pi electrons are present. So that will make this particular around this compound there is a negative field will come. So automatically the H plus will approach the pi bond. You can see. So what will happen? Again, this will undergo polarization. So either it can move towards this carbon atom or it can move towards this carbon atom. So if it is moving towards right, what will happen? Automatically again the plus charge will come at this particular carbon. So that will create a tertiary carbocation. So the polarization will happen in this direction and you will get positive and negative charge. Now again, as like the similar steps, the H plus will first approach the negative charge. So you will get the reaction intermediate. This is our reaction intermediate. Now again, what will happen? In the next step, the nucleophile will approach the positive charge and you are getting the same compound. Correct? So from this you can say both A and B should be my correct answer. Correct? Easily say. But there is one more important point I want to make notice of. I am taking the third option also. Just this is for studying actually. I need to know what will happen here also. So here also you have the pi bond is present. Now again HCl undergo heterolytic fission. The H plus will approach the pi bond first. Now again the polarization will happen. Okay, now you can ask a question, sir. Now the polarization happens. Suppose here positive charge is coming and negative charge is coming. This is a secondary carbocation. If positive charge comes here also, there is a secondary carbocation. Then why you have polarized like this? You can ask this question. The reason for that is when positive charge comes to this particular carbon, we can see a nearby tertiary carbon is present. So that means there is a possibility of rearrangement. That is the reason it is polarizing in this way, so that positive charge will come to this particular carbon. Okay. Now again H plus will attack the negative charge like this. And now the positive charge here is a secondary carbocation. It will check always to become more stable. So it will what it found here, 4 valencies are there. The 4th valency is a hydrogen atom. So the hydrogen along with the 2 electrons are present in the nearby carbon atom. So what it will do, this hydrogen along with the pair of electrons will have a tendency to move towards a positive charge due to hydride shift. We call that as 1,2 hydride shift. So when the pair of electrons comes to here, automatically the vacancy will come here. So positive charge comes here. So you are getting a carbocation, tertiary carbocation. Now the nucleophile will attack here and you are getting the same product. Now comes the doubt. Sir, while looking at the options, there is no option like 1, 2 and 4. So how can I choose the answer? So please understand, here comes the twist. Here comes the importance of the line. Here comes the importance of the line. Accordance with the Markovnikov's rule. Can you think and say whether Markovnikov's rule states anything about carbocation rearrangement? No. It talks about whenever an addition occurs across an unsymmetrical alkene, the negative part of the addendum will go to least hydrogenated carbon atom. This is what it says. Okay, there is no carbocation rearrangement. So that is the reason why even though we are getting the same product for this one, I can ignore the option 4. My answer would be option 3 would be my correct answer. Hope you are understanding. Okay, so this question is very, very important. Some students may think like the question itself is wrong. Okay, and they may leave the question, but you will be the loser in that case. Okay, hope you understood. Now that I am giving here as an important tip, so the Markovnikov's rule does not state, it does not mention anything about carbocation rearrangement. So you can ignore that particular option. Okay, we can say it is not according to Markovnikov's rule. Clear? I hope you understood. Now let's go to the next question. It's a very important question. Until now it is not asked for Neet, but you can expect. Okay, so here also if you see here, analyze this question, you have an HBr. Okay, in the compound there are multiple pi bonds are present, and again I am telling when pi bond is present along with the benzene, we know that this is under delocalization. Here delocalization, so I can say addition will not occur across the benzene ring. Next, the pi bond is present between carbonyl group, and we know that carbonyl will group always polarize in such a way that CO minus and plus charge will come. Why? Because the oxygen is a more electronegative atom, so the pi bond will always move towards an electronegative atom. As a result, a plus charge will come here. So when oxygen with the minus charge is a stable species, you can see already 2 lone pairs are there, and positive charge will come on the carbon atom. So surely addition will not occur here. It will occur, it would be a nucleophilic addition. But here we have H plus and Br minus. So what will happen fundamentally? I can easily say the H plus will approach only the pi bond that is present here. You can see the pi bond that is present here will get attacked by the H plus. Now we will see the mechanism. Okay, it's again the same thing, sir. So I can say here, you can see in this video, so HBr again will undergo what sort of fission, sir? Heterolytic fission. So you will get H plus and Br minus. So what will happen? Pi bond is present here. All together you can see many pi electrons are present. Okay, now many students may ask a doubt, sir, in that case why can't we think about a situation where the Br minus is a nucleophile? Can it go to carbon atom and attack that and initiate the reaction? But please understand, if you see altogether this compound, what charge is present? Because of the pi electrons, huge amount of pi electrons are there, 6, 8 and even 10 pi electrons are there. So there is a huge negative cloud is present, negative charge cloud is present. So of course it's very difficult for the Br minus to approach this molecule very fast. So H plus will be moving very fast. That is the reason most probably it will undergo electrophilic addition. So it will approach the pi electron here. Then it will undergo polarization plus and minus like this. Here also students may ask, sir, why it is polarizing in this way? Why it can polarize like this and create a negative charge here and a positive charge here? The reason for that is when the positive charge comes here, I can easily say that positive single bond, double bond, single bond, double bond. So this carbocation will be stabilized through resonance. But if you have the positive charge in the other carbon, this one, I can easily say there is no resonance for the carbocation intermediate. So that is the reason you can easily say here H plus will attack this negative charge and you will get a carbocation intermediate. And this is stabilized by what, sir? I have written SBr, that means stabilized by resonance. Now what will happen? Again the same step, nucleophile will come and attack the positive charge and you get a product like this. Okay, so now it's very easy, right? You can easily imagine the steps that is happening in a nucleophilic addition reaction. Can you tell? So in the first step, who will come? Electrophile. Electrophile will approach whom? Electrophile approaches pi bond. Electrophile approaches pi bond. This is the first step, pi bond. What is the next step, sir? When electrophile approaches the pi bond polarizes. Pi bond polarizes. Then what will happen? Electrophile attacks the negative charge. Electrophile attacks whom? Negative charge. What you are getting? Attack negative charge. You are getting a carbocation. So C plus means carbon with a positive charge. Carbocation intermediate. Carbocation intermediate. Clear? Next step, what will happen, sir? The nucleophile present there attacks the positive charge in carbocation. So if you do these 5 steps, almost all questions you can do, nothing else, sir. First step, identify the electrophile, go near the pi bond polarizes. There you need to make a judicious decision in which direction it should polarize based on the stability of carbocation. Then what you need to do? Make the plus charge attack with negative charge. Then a carbocation intermediate will be formed. Check for rearrangement. Carbocation intermediate should be formed and check for rearrangement. Why? Because rearrangement can give you a more stable compound. Check for rearrangement. That is very important. Then the nucleophile attacks the positive charge in the carbocation. That's it. Very simple. Now, what is the answer, sir, in this case? Can you tell me? So here I have from the given options, I can easily say my answer here would be option 2 would be my correct answer. Correct? I hope you understood. It's very easy. Okay. Now we'll do one more question for practice. So this is the question for you. So here you can see one more thing I have done. There are 2 pi bonds are there and I am adding 2 molecules of HBr. That is the only difference. So continuously you need to perform 2 electrophilic addition reaction. Nothing else. Clear? So we will try to do how this happens. Now some students may ask a doubt. Sir, where the first addition will occur? Where it will occur here Okay, let me change the color, where it will occur here or here. Again, that depends upon, again I can say that depends upon where the charge density of the cloud, electron cloud is more. I can easily say here OCH3, the methoxy group is a plus some group. What sort of a group is that? Plus some resonance group. So what it will do, it will increase the electron density near this location or to this particular carbon. So surely the first electrophilic addition occur at this particular site. Hope you understood. Now let's analyze it further. So you can see here, this is my compound. So again, the HBr will undergo polarization, H plus and Br minus. Again, as I told, because of the plus sum effect. Plus sum effect means it will donate electrons to the conjugated system. So this will donate electrons to the system. So automatically here, what will happen? The electron density increases, and I can easily say the H plus will attack this pi bond. So again, this will polarizes. So again, big question comes, sir, plus will come here or negative will come here. How I can identify? Very simple, sir. Lone pair, single bond, positive charge. So this means this is stabilized by resonance. But if negative charge comes here, negative single bond lone pair, it can undergo repulsion. So there is no resonance. So I can easily say the pi bond polarizes like this. So it is not, I am just roughly writing after putting both combinations, and I am thinking how this carbocation can get stabilized. Only way is resonance or hyperconjugation. So if there is a possibility of resonance, I will consider that and will do the polarization in the correct way. Now what will happen, sir? As our steps, H plus will attack the negative charge and you will get like this. Then what will happen? The nucleophile will come and attack the positive charge and you will get the first compound. But here the reaction is not stopping because they have one more pi bond here. And also there is one more HBr molecule is waiting or ready to undergo electrophilic addition. So let's see that. So again, I am taking that as my starting molecule and I am splitting it. So you are getting H plus and Br minus again. So what will happen? Again, H plus will attack the pi bond. Now also the questions are how it will polarize. You put it both direction. Suppose you put plus here and a negative here. I can easily say the carbocation is a secondary carbocation. But if you polarizes in the other way, how is the other way? Like this. Then negative charge will come here and a positive charge will come here. So I can say this is a tertiary carbocation. So H plus will attack here, and moreover you can see here there are two hydrogen would be there. Here also two hydrogen would be there. So totally this is an alpha carbon, this is my alpha carbon, and this is also my alpha carbon because all these are connected to the positive carbon. Nearby carbons are called alpha carbon. So totally I can say here 2, here 2 and here 3. So 3 plus 2 5, 5 plus 2 7 alpha carbon, 7 alpha hydrogens are stabilizing this carbocation through hyperconjugation, SBH, stabilization through hyperconjugation, stabilization through hyperconjugation. And also you can say there is plus I effect from CH3 group. Here CH2 group is present. Here also you have CH2 group is present. So all these are through plus I effect also this carbocation is highly stable. Now what will happen, sir? The last step, I can easily say the Br minus. The Br minus will attack this one, this positively carbon, and you are getting 2 bromine at the 2 corners. So I can easily say from the given options, which would be my correct answer, sir? I can easily say the answer would be option 1. Correct. I hope all of you are understanding this. At any point, if you are finding it difficult, feel free to ask it in the comment box. Okay, so I hope today you have enjoyed the 3 important questions for electrophilic addition reaction. So tomorrow also we will continue this and we will thorough this particular session, electrophilic addition reaction. It's very important. It's one of the very important reactions of alkenes. Okay, thank you.